This is the solution for the 2008 AP Physics C problem number 3. Problem number 1. The skier with air resistance. And we have a skier skiing down a frictionless slope. There's the skier. The skier has mass m. The force of air resistance on the skier is negative BV. So this is going to be our differential equation type situation here. And I think those are all the constants that we need. So first problem, they have part A, basically free points to be had here. On the dot here, they want us to draw a free body diagram indicating and labeling all the forces that act on the skier while the skier descends the hill. Well, there's gravity, and what else? There is the force of air resistance, which acts exactly opposite the direction of motion, like all frictional forces do. That's air resistance. And then there's one more. I suppose that's the one you might forget. Because this is on a surface here, there is also the normal force stopping the skier from accelerating toward the center of the Earth uncontrollably, which would be weird. So those are the three forces that are acting on the skier: the normal force, air resistance, and the force of gravity. In part B, they want us to write a differential equation that can be used to solve for the velocity of the skier as a function of time. So they're skipping the intermediate step of finding the terminal. Oh no, that's in part C, but they're not doing that first. So let's see. The net force on the skier is equal to, well, we need to figure out, I'm not going to draw it on here because that's the answer to some other part, so maybe I'll draw it up here. Here's the gravitational force, and the components of that, if this is theta, then this is also theta. This is adjacent to that, so this is f of g cosine theta, and this is f sub g sine theta. So the cosine component is canceled out by the normal force. The skier is not accelerating in that direction. The skier is accelerating in this direction. So the net force on the skier is this force minus the air resistance force. So taking downhill to be positive, that would be m. I'm using a capital M because that's what they used to try to be consistent with their notation. mg sine theta, that's the component this direction down the hill, minus bv. Alright, now they want a differential equation that could be solved to find the velocity. So let's see. This is mass of, again, capital M because they used capital M. So ma equals mg sine theta minus bv. So m times dv dt, replacing acceleration with derivative of velocity. And that could be your answer. You could divide through by m if you want to. It really doesn't matter. So let's go ahead and do that because we're going to need to solve it later anyway. So dv dt equals dividing both these terms by m, g sine theta minus b over m times v. So I will report that as my answer for part B, although this would be a perfectly acceptable answer too. Part C, determine an expression for the terminal velocity. I'm going to go ahead and write down the versatile terminal velocity happens when acceleration is equal to 0, and that's the same as saying that the net force, so the force equals mass times acceleration. No acceleration means no net force. So going back to here, we'll set that equal to 0. 0 equals mg sine theta minus bv. So, and that's terminal, right? This is terminal, so don't forget to put that in there. So terminal velocity happens at mg sine theta over b. That's solving that for terminal velocity. I wrote this down because having gone through many scoring rubrics, I know that if I make a statement like this, that's probably worth a point. Maybe even 2 for writing things down along the way. So get in the habit of doing that. And now, part D, we're supposed to solve the differential equation from part B. So I'm going to go ahead and just copy that down again. dv dt is equal to g sine theta minus b over mv. And we've done this before, so we know the direction this is going to go in. It's going to be some kind of exponential decay. So let's see. We need to move all of this over here. So 1 over g sine theta minus b over mv dv is equal to dt. And the skier is starting from rest at time 0, so I'm going to do the same trick we did in your notes. At t0, velocity is 0, and this is a variable t, the variable. We have that double roll problem, but we'll deal with that. Just be careful. So the antiderivative of this, you do a u substitution, u equals the whole bottom of this, g sine theta minus b over mv. So du is, that's just a constant, so that's 0. Derivative of that is minus b over m dv. So let's see, I don't have, means I need a minus b over m in here, which means I need a minus m over b out here. So that turns into minus m over b, and this whole integral is now 1 over u du. That is natural log of u, which is g sine theta minus bm over v. I'm being careful here to show all steps because they ask me to. So going from v equals 0 to v, and then over here the antiderivative of dt is just t from 0 to t. So plugging in the v gives me this expression, so I have minus m over b natural log g sine theta minus b over m v minus you know what, I think I'm going to go ahead and on this side we're going to end up with the t, and instead of having this over here, I think I'm going to go ahead and move that right now, minus b over m on the other side, so I don't have to have the double negative signs and all that. So that just gets rid of that. Move that to the other side with the t. And plugging 0 into this, natural log of g sine theta. And that goes away. So let's see. Logarithm rules. I can say that's the natural log of g sine theta minus bm over v all over g sine theta is equal to negative b over mt. And now I exponentiate. The e and the natural log cancel out, and I get g sine theta minus b over mv is equal to, and then on this side I have e to the minus b over mt. This would be on the bottom here. I'm going to multiply it to the other side. and moving things around a little bit, moving this over to this side, subtracting this, I would have b over mv is equal to, I moved this over here, so let's see, it would be g sine theta minus g sine theta e to the minus b over mt. And what happened to the b over m? Well, I'm going to multiply m over b to this side. That is an expression for the velocity. I should write it as a v of t at any given time t. That's a mess, but probably if you look through the rubric, you're going to get good points for setting up any of these steps and making it, even if you don't make it to the very end. That's the hard part, or hardest part of this problem. And last, part E. This one's easy if you remember what these graphs look like and you apply a little bit of logic here. We have an acceleration versus time graph. And they want us to take downhill as positive. So indicate the initial value of the acceleration. Well, the initial value of the acceleration when the skier is at rest is g sine theta, right? That's that first value before, oops, when the velocity, remember this is acceleration here, before the skier started moving, the velocity is 0, so the acceleration is just g sine theta. Or in other words, before there's an air resistance force, before they're moving, the net force is just that component down the hill. If you just put a here, then you're probably going to lose a point, but that's not the end of the world. The shape of the graph is much more important and worth more points, I would think. So that's their initial positive acceleration. Now what happens as time continues on here? Well, the air resistance force grows and the net force approaches 0, right? Because the air resistance force grows until they're the same, at which point you reach terminal velocity. And since the velocity is the slope of this graph here, oops, sorry, that's not true. Scratch that. It's the wrong way around, right? So we know anyway that the acceleration, if force is going to 0, then acceleration is also going to 0. So if this is approaching 0, it can't approach like this because that would force it to cross. It's approaching in an exponential decay type of fashion, like this. And that's really all they're looking for. In the rubric, I would guess, I haven't looked at it, but it would say something about the graph being decreasing and concave down and not crossing the t-axis. So something like this. And if you have that, g sine theta, then I think you're getting full points for that.